Good evening, everyone. It's about 10 to 9 here. I'm student meteorologist Eric Drewitz with Weather International. Currently looking across the northeastern United States, we have temperatures ranging from the upper 50s and lower 60s over northern Maine and into the province of Quebec. And then getting down into Maryland and northern Virginia, we have temperatures in the upper 70s to lower 80s. And then looking across central Pennsylvania right here, we have temperatures in the middle to upper 70s with dew points ranging from about the middle 50s to the middle 60s, so it feels quite comfortable outside. Looking at the current satellite imagery, we have some moisture to our north, moving out of the province of Ontario into the province of Quebec, and looks like some moisture is starting to move into our region with drier air to the south and east. Looking at current radar imagery, things are looking pretty quiescent around the area, except for a few spotty showers and storms that are moving off and primarily to our east now. And then moving into the current 0Z GFS 500 millbar wind analysis, we have a minor trough in the east, but a huge ridge in the west that is responsible for some real excessive heat over that region. Areas in eastern Washington state superseded the century mark, as well as areas down in Arizona and Southern California received temperatures of over 110 degrees due to this ridge. Now moving more into your forecast here, this is the GFS 500 millibar heights, vorticity, and wind. And looks like we have some areas of upper level energy moving into our region about Monday evening. This is 0Z Tuesday. And then again, for the Euro, we have upper level energy moving pretty close to our region around this time as well. Looking at the NAM now, this is the 18Z run on the NAM, and again, we have upper level energy moving into our region at this time, so I mainly want to focus on Monday evening, because that's when it looks like the weather might be the most interesting across central Pennsylvania. So now moving into looking at some 700 millibar moisture. I actually was looking at this earlier, and we actually have drier air aloft here at 700, as you see around central Pennsylvania. But then over at 850, we have more moist conditions. So what that means is when you have lower moisture at lower levels with dry air aloft, that's really good for instability. And because moist air is less dense than dry air, you're going to have more rising motion due to this density difference. And looking at the European for 0Z on Tuesday or 8 p.m. Eastern Daylight Time Monday evening, again, it looks like we have more moisture at 850 than 700. So this could definitely trigger lift and more in the way of elevated convection for thunderstorms. Now, moving into looking at instabilities as a whole, we're looking at the CAPE, or the convective available potential energy, as well as the SIN. So the more CAPE you have, the more unstable the atmosphere is, and then the more SIN you have, the harder it is for a parcel to reach its LFC, or its level of free convection. That anywhere above that level of free convection, that parcel is pretty much going to be positively buoyant. It'll just keep rising until it gets to the equilibrium level. So the more SIN you have, the less likely, in other words, to break it down for you even more, the more SIN you have, the less likely thunderstorms are going to develop. Doesn't matter how much CAPE you have. If you have a lot of SIN but no lift, you're not going to get thunderstorms. If you have a forcing mechanism with little SIN and lots of CAPE, you're going to get really nice thunderstorms. So anyway, moving into looking at the NAM, GFS, and Euro right here for 0Z on Tuesday, there's a decent CAPE throughout the region on Tuesday, especially according to the NAM. Now, for scenarios like this, I actually like to look at the NAM more than other models, because the NAM is what's known as the North American Mesoscale model, and that means that it's geared more towards forecasting things like severe weather, thunderstorms, due to its smaller grid spacing and its higher resolution than the GFS and the European models. So now looking at the SIN, at the convective inhibition right here, it looks like it's pretty weak across the region at this time. So, late Monday afternoon into early Monday evening, central Pennsylvania could be seeing some decent thunderstorms so far. And now looking at some more water vapor indices. This is precipitable water for 0Z on Tuesday, and again, it looks like we have a plume of higher precipitable water values throughout the northeastern United States, according to all three models. So that also supports the development of thunderstorms. So, like I said, just a quick recap for everyone. We have that upper level energy coming in from the northwest. We have moisture at lower levels with dry air aloft. We have higher precipitable water values. We have a decent cape and not that much sin. So that's already showing good ingredients for thunderstorm formation. Now, looking at some model cross sections here. This is the 18Z run of the NAM. This is for State College, Pennsylvania. And again, we have plumes of high relative humidity values right before 0Z on 0Z Tuesday. So, in other words, Monday afternoon to the evening of extending upwards pretty high above 300 millibars. So this implies, since we have plumes of high relative humidity extending up this high at these times, it implies that we have rising motion that's going to bring up this low level moisture, and combined with that elevated convection, you'll have some real good thunderstorms at this time. Now looking at this is, again, the 18Z NAM, except we're looking at a cross-section of potential temperature with height and time. Over 0Z on August 4th, or 8 p.m. Eastern Daylight Time on Tuesday, so Monday evening. Again, it looks like we have not as much of a gradient between potential temperature. In other words, the potential temperature lines are more spread out, which means the atmosphere is more unstable. So, that being said, again, this is now just to corroborate with the GFS right over here. August 4th, we have another, again, the GFS shows another plume around the same time as the NAM of high relative humidity values extending above 300 millibars. So, that implies, again, lift. That implies, decent environment for thunderstorm formation. And again, here's the potential temperature. And again, around August 4th, we have very little potential temperature change in height right before 0Z on the 4th. So sometime Monday afternoon into the early evening, we have very good instability around here to create and trigger thunderstorms. Well, I shouldn't say trigger, but have a good environment for thunderstorms. However, there will be a trigger with that upper level energy coming in to trigger thunderstorms. So now, looking at more severe weather parameters, here's the 0 to 6 kilometer wind shear. And this is the NAM currently that we're looking at. And here's 0Z Tuesday. And as you see, we have areas like State Colleges and areas of 35 knot wind shear, almost 40 knot wind shear. So that looks really good. The wind shear, actually increases a little bit overnight. So the more wind shear you have, the better chance you would have of thunderstorms. Wind shear is good for thunderstorm development as well, especially supercells. Although I don't think we're going to see much in the way of supercells. I think if anything, we're going to see more what's known as MCSs, or mesoscale convective systems, which are the squall lines essentially that you're used to seeing in the Northeast over the summer, or a line of thunderstorms. So now looking at some forecast soundings on Buffkit here. This is for UNV, or State College, Pennsylvania. Here's the 18Z NAM for Monday, August 3rd at 8 o'clock p.m. So this is actually for 0Z on Tuesday. And as you see, we have CAPE values of about 545 joules per kilogram, and SIN about 71 joules per kilogram. So I think CAPE is decent, and the SIN's small. However, usually I like to see CAPE values of at least 1,000 joules per kilogram. However, we do have a decent profile here for thunderstorms. I mean, we have a very strong negative omega too, which really implies, lifting is occurring. And then looking at the 12Z NAM sounding, because the 12Z NAM sounding was more impressive. Now, I do like to look back at older models, just because 12Z models do have very wind-son data put into them that the 18Z and 6Z don't. 0Zs and 12Zs do, but 18 and 6Zs do not. So looking ahead here at 8 p.m. or 7 p.m., we have Kate values of about 1,500 joules per kilogram and SIN only 8. So conditions do look pretty favorable. There is some decent shear aloft, like I showed you in the model run before. And I did look earlier at the helicity, the 0 to 1 helicity. Although the helicity, the reason why I don't think tornadoes are going to be really a factor here, because helicity, the 0 to 1 helicity over central Pennsylvania was relatively small. So that does not support tornado formation. So this has been your forecast. I'm student meteorologist Eric Drewitz with Weather International signing off. Thank you all for watching and have a great day.